In this session, we discuss the working of a dynamo or AC generator. It is working on the principle of electromagnetic induction. And actually it's a device which is converting mechanical energy into electrical energy. Means we mechanically rotate the coil inside the magnet. Now let us see how it is. N and S are called field magnets. Means north and south pole of a field magnet. Field magnet means that provides necessary uniform magnetic field for the working of the dynamo. Now in that magnetic field, a rectangular coil is kept. That rectangular coil is called armature. Rectangular coil is called armature, and the two ends of the rectangular coil are connected to two slip rings. These are metallic rings, and ends of the armature coils are connected to two metallic rings. And metallic rings are now attached to what you call a carbon brush. See this? These two are carbon brushes. Carbon brushes is nothing but a contact points. And through that we can get the output. So, as we rotate this armature coil in this magnetic field, there is an induced current is developed in this one, and that induced current is tapped through this ring brush system, and we can get the output. So, field magnets, armature coil, slip rings, and carbon brushes. These are the main parts of what you call a dynamo or AC generator. Now let us see the theoretical part of this one, how it is working or how it is generating the EMF. Let's see. Now you know that according to Faraday's law, the induced EMF E is equal to minus d phi by dt, where phi is the magnetic flux linked with the coil. Now here the flux phi will be equal to N times A into B into cos theta, where cos theta is the alignment of this coil with respect to the magnetic field. So phi will be equal to NAB into cos omega t, we can write. Means as you rotate this coil with an angular velocity omega is the angular velocity, then that angular velocity into time gives you the angle through which it is turning in the magnetic field. Now from this magnetic flux, N is the number of turns of the armature coil, A, area of the armature coil, and B, magnetic field, we can get the flux equation like that. Now if I bring this into this one, I get induced EMF is equal to minus of d by dt of NAB cos omega t, I could get. Now doing this differentiation, I get NAB, all these three are constant. Omega is also constant, I could say, as it is rotating. Then the cos omega t is the variable there with respect to time. So dy by dt of cos omega t, I get it as minus sin omega t. That means minus of minus plus, and I get that equation as NAB omega sin omega t. So this is the flux equation, instantaneous flux equation, and this is the instantaneous induced EMF equation. Now NAB omega, all these are being constants. I can write the equation as E equal to, this I can take it as E0 into sin omega t. Now when this sin omega t is maximum, right? That is sin omega t being 1, you get the maximum value here, and that maximum value is taken to be E0. So I can write the output of the AC generator as E equal to E0 sin omega t, or generalizing V equal to V0 sin omega t, where that V0 is called peak value of the output. Now you can see the output is varying just like a sine wave. So if it is varying just like a sine wave, and if you represent that output in the, what do you say, the graphical form, you see this graph. The graph shows that omega t, then this is V, then you can see the graph varies like this, and effectively the peak reaches 1 pi by 2, and the negative peak comes as pi by 2 pi by 2, 3 pi by 2, and here is pi, and here it is 2 pi. So this is the sine wave output you are getting, and we call this as an AC output, alternating voltage output, I could say. And that is why the generator is called AC generator. And this is the way we represent an AC voltage. And the details of this AC you will be studying in alternating current AC, the chapter. But AC is generated using what you call dynamo, based on electromagnetic induction. Okay, so what is an alternating voltage? See this, it's a varying voltage, it varies instantaneously, periodically changing its direction. So an AC will be having a definite time period for its propagation. Alright, now another point to be noted from this is that you might have seen the thing, the flux is found to be, the flux phi is equal to NAB cos omega t, and the induced EMF is found to be NAB omega sin omega t. So between the flux and the output voltage there is a 90-degree phase differences coming. This is also to be noted. And another point to be noted is that when you say the angle omega t equal to 0, the flux is maximum, but the induced EMF will be 0. And if I say omega t equal to pi by 2, flux becomes 0, but induced EMF becomes maximum. So there is a lagging between the two. Don't think that when the flux is 0, induction is there. No, it is not like that. Induced EMF is due to the change of flux that is coming. Alright? And that is why this is happening. Alright? So, this is all about what you call AC generator. And one extra point, how we can get a DC output. We can use the same instrument to get a DC output just by changing this commutator system. This is slip ring. Suppose I take split ring commutator. Split ring commutator. This split ring commutator gives an output which is DC. Not perfect DC, it is a fluctuating DC, out of which we can get a perfect DC. So just by changing the slip ring into split ring, we can obtain, or we can change the AC generator into a DC generator.